Black holes are among the most dangerous things in space. They can rip apart even stars and not let them go until they turn into spaghetti. If anything comes too close to it, that thing will be ripped apart by the black hole and then get sucked inside. But it seems that gravity near black holes does some other strange things too. It can slow down time itself. Time near black holes moves slower than it does far away from them. Let's take an example. Imagine you have a friend named Alex who is watching you from Earth while you're flying around in a spaceship that has an incredibly powerful engine. With this engine, you approach a black hole at almost the speed of light. According to Alex, you are approaching the black hole at a very high speed, but according to you, you are just moving at a normal speed. You start to pass by the event horizon of the black hole and reach 99% of the speed of light. When you are 99% of the way through the event horizon, Alex sees you moving at 18 times faster than the speed of light. This doesn't make any sense because nothing can move faster than the speed of light. So what's going on here? Well, remember that all measurements of motion are relative. They depend on your frame of reference. And as you get closer and closer to a black hole, the frame of reference of the black hole takes over. The gravitational field of the black hole is so strong that it completely changes our usual rules. There is no place for absolute motion. Everything is relative to the black hole. To understand this phenomenon better, we need to use Einstein's theory of special relativity. In this theory, there are two postulates. The first postulate says that the laws of physics are the same in all non-accelerating frames of reference. In other words, there is no preferred frame of reference. All frames of reference are equally valid. The second postulate says that the speed of light in a vacuum is the same for all observers. No matter how fast you are moving yourself, you will always measure the speed of light to be the same. These two postulates lead to some weird consequences, such as time dilation. Time dilation means that time passes differently for two observers who are moving relative to each other. The faster one will experience time more slowly than the other. For example, if you were to move really fast in a spaceship, say 50% of the speed of light, time would pass more slowly for you on your spaceship than it would for someone standing still on Earth. If you were to come back to Earth after traveling at half the speed of light for a year, you would find that less than a year had passed on Earth. But it gets weirder than that. The closer you get to a black hole, the stronger its gravitational field becomes. And the stronger the gravitational field, the slower time passes. This means that if you were to get close enough to a black hole, time would pass much more slowly for you than it would for someone far away from the black hole. And the closer you get to the black hole, the slower time would pass for you. This is what happens with you passing the black hole. From Alex's point of view, he sees you passing the black hole. But from your point of view, time slows down to a halt when you reach the black hole. When you cross the event horizon, you are completely cut off from the outside world. Alex cannot see anything beyond the event horizon, not even light. He can only see up to the edge of the event horizon. Once you pass this point, he can never see you again. But let's go back to the moment when you are at 99% of the speed of light while approaching the black hole. At this point, you are so close to the black hole that its gravitational pull is extremely strong. As a result, time has slowed down dramatically for you. According to Alex, you are now moving faster than the speed of light. But how could this be possible? Well, it's possible because of the warping of space-time caused by the black hole's gravity. Remember that space and time intertwined in a four-dimensional fabric called space-time are affected by gravity. The stronger the gravity, the more space-time is warped. The warping of space-time near a black hole is so extreme that it causes what is known as a singularity. A singularity is a point in space-time where gravity becomes infinite and all the known laws of physics break down. As you continue to fall towards the black hole, you will eventually reach the singularity. Here, everything would be ripped apart and crushed together into an infinitely small point. So what happens next is anyone's guess. Some scientists believe that the universe as we know it began with a Big Bang. If that's true, then it's possible that our universe is just one of many that have been created and destroyed throughout eternity. Maybe there are other universes out there that are completely different from ours. We may never know for sure, but it's fun to think about the possibilities. What do you think happens near black holes? Let us know in the comments below. Now let's get back to the video. As you approach the black hole, you will see that the stars begin to disappear one by one until only darkness remains. You will feel an intense gravitational pull that will tear apart your spaceship, but before you are ripped to pieces, you will see something truly amazing. You will see the universe itself begin to collapse in on itself. The stars and planets will be pulled together until they form a giant ball of matter. You will see the galaxies spin around and crash into each other. The entire universe will be in chaos. And then, you will be no more. You will be ripped apart by the black hole and then swallowed into its endless abyss. What happens next is anyone's guess. Maybe you will be transported to another universe, or maybe you will simply cease to exist. One thing is for sure, you will never be seen again. That is the fate of anyone who gets too close to a black hole. Now let's talk about why this happens. It all has to do with the warping of space-time. Remember that space and time are intertwined in a four-dimensional fabric called space-time. The presence of a black hole distorts this fabric in such a way that nothing can escape its grasp, not even light. This is because the gravity near a black hole is too strong. Gravity warps space-time, and the closer you get to a black hole, the more space-time is warped. Eventually, the warping becomes so extreme that it creates a singularity. A singularity is a region of space-time where gravity becomes infinite and all the known laws of physics break down. Once you cross the event horizon, there is no turning back. Nothing can escape from a black hole, not even light. This is why we can never see inside a black hole. The light that is emitted from the interior of a black hole is never able to reach our eyes. It is trapped inside the black hole forever. The only thing that we can observe about a black hole is its boundary, which is known as the event horizon. The event horizon is the point of no return. Once something crosses the event horizon, it can never escape from the black hole, not even light. The event horizon of a black hole is not a physical thing. It is just the boundary of a region of space-time. However, the gravity near a black hole is so strong that once something crosses the event horizon, it is pulled towards the center of the black hole. As it falls towards the center of the black hole, it is accelerated to incredible speeds. Eventually, it reaches the speed of light. At this point, time stops for the object. From our point of view, we see the object falling towards the black hole, but from the object's point of view, time has stopped. As the object continues to fall towards the black hole, it is crushed together and heated to unimaginable temperatures. Eventually, it is ripped apart and slung into the black hole. Once it crosses the event horizon, it is lost to our universe forever. It is hard to imagine what would happen if you were to get too close to a black hole. The gravity would be thousands, if not millions times greater than the Earth's gravity. You would be utterly crushed and then torn apart. But if somehow you were still alive, you would only last a few seconds. The temperature near a black hole is millions of degrees. You would be burned to ashes in a matter of seconds. However, there is a theory that says that if you were to get close enough to a black hole, you would be able to travel back in time. This is because the gravity near a black hole is so strong that it warps space-time. If you were to fall towards a black hole, you would be able to travel back in time. The amount of time you would travel back would depend on how close you got to the black hole. The closer you got, the further back in time you would be able to travel. If you were to get close enough to a black hole, you would be able to travel back in time and see the beginning of the universe, but of course, this is just a theory. We don't really know what would happen if you got too close to a black hole. But it is a fun theory to think about. What do you think would happen if you got too close to a black hole? Let us know in the comments below. Thanks for watching. If you like this video, please leave a like and subscribe for more videos like this.